Now. Is everything fine now? Okay, good. Very low. What now? I disconnected the microphone because maybe it's not working for now. So I'm using just my laptop's microphone. Sorry for that, sorry for these issues. How was the contest today? How was the contest for you, guys?
For example, you see like there.
I don't know why. Okay, so I see. So we're gonna solve the problems today. So I hope that it can help you understand all the solutions of the problems. We're gonna discuss them all now. Are you ready to start with the first problem? Is everything fine? Okay, so let's start talking about the first problem. Let me bring the statements. Legs. It says that we have a farmer and he counted the legs of his animals and he has seen n legs. We know that a chicken has 2 legs while a cow has 4 legs. What is the minimum number of animals Farmer John have on his farm, assuming he counted the legs of all the animals? Well, first of all, we can say that we know that each chicken has 2 legs and each cow has 4 legs. So definitely it's better for us to have more chickens if we want to have the maximum number of animals. Chickens are better because instead of each cow you could have 2 chickens, right? So sorry, we want minimum. So instead of each 2 chickens, we can have 1 cow because the answer wants the minimum. Instead of each 2 chickens, we can have a cow. So it's the best to use as many cows as possible, right? It's the best for us to use as many cows as possible. So what we can say is that if we have seen n legs, we try to have as many cows as possible, each of them. So each 4 legs will be for 1 animal. 4 legs will be 1 animal. If at the end there was some remainder, or in other words, the n is not divisible by 4, then we will have a chicken at the end. So the point is that in here we will have at most 1 chicken. If n was of form, we know that n is an even number. As we can see in here, n is even, right? So we know that n is even. So n is either of form 4k or n is of form 4k plus 2. If it is 4k, it's like we just have k cows. If it is of form is of form 4k plus 2, we have 4 k cows and 1 chicken. In other words, we can say that the number of animals, the answer, is equal to floor of n plus 2 over 4. This means that if n was of form 4k plus 2, when you add 2 to it, then dividing it by 4 gives you k plus 1. If n is of form 4k, by adding 2 the floor of its division by 4 does not change, so it will remain as k. So we can simply say that in order to calculate the answer in here, we can just say this. We can see in n and see out n plus 2 over 4, and we know that automatically by default when we divide n plus 2 by 4, it calculates the floor of that number when everything is in, where all the values in here are integers. So it calculates the floor. So we see in n and see out n plus 2 over 4. Is it clear? If you are okay with that, please again use this emoji and we can move on to the next. Yeah, this problem was an easy one. Yeah. So, awesome. So, let's move on to the second one, problem B. Well, problem B scale states that we have a square of n rows and n columns. We want to reduce the grid by a factor of k. Let me just make sure that everything is okay. Okay, so we want to reduce everything, we reduce the grid by a factor of k, and k is a divisor of n. In order to do this, we can take every k by k non-overlapping blocks of cells, and it is guaranteed that they all have the same value. Every k by k has the same value. For example, in here, k is 3 and n is 6. It is already guaranteed that these blocks of 3 by 3 have the same value. All of them are 0, all of them are 1. You have to say that what is going to be the final array. For example, in here, you can see the example given to you in here. When you reduce it, every 3 by 3 is guaranteed to have equal numbers. So the first 3 by 3 is 0, as you can see here. As you can see, in here. The second one is 1. The one below is 1 in here. The one in here is 0. So when you reduce it by a factor of 3, it will be like this. So how could you solve this problem? But this one is also easy. We can just say that, okay, you want to solve it, you just do this. You have a 4 I and j. You have a 4 of I and j and you can each time increase I and j by k instead of increasing it by 1. So first of all, print the cell 0 and 0, then go to the cell 0 and k, then go to the cell 0 and 2k, and then go to the cell k and 0, then k and k. It's like from each k by k, I'm just giving in my output, I'm giving the cell at its top left. By doing this, I can find out all the numbers because I know all the values are exactly the same as what we see in here. All these values are the same as what we see in here. So if we can just have a 4i, just in my I each time I increase it by k, and then inside this I have a 4 on j. Instead of increasing it by 1, again I just increase it by k. Then I will have my final grid reduced by a factor of k. And as you can see in this code, it's nothing other than this. I see in all the strings, I see in the grid, and there I have 2 4s, and the only thing is that each time I increase I and j by k. This time it's like I skip all the cells which have the same number as this one, which are at the same block. I go to the next block, and from each block I'm just printing the cell located on its top left. I just print that and it's gonna be my answer, my final answer. Okay, is it clear? Shall we move on to the next problem? Awesome. Okay, let's move on to problem C now. Problem C, source. You are given two strings A and B of length n, and you have to answer Q queries. In each query, you have to say that if you consider all the elements from L to R in the first one, and all the elements from L to R in the second one, in the second sequence, in the second string. First of all, we know that they are all they all consist of lowercase English letters. We just say that if you consider them, how many elements of A you need to change in order to make the sorted version of them equal. I mean, in order that at the end, when we consider these two intervals, if we sort them both, they are equal. What does that mean? What does that mean that the sorted version of them are equal? It means that from each character, they should have an equal amount. So what I mean is that if we consider these two intervals, if we consider these two intervals in these two strings, we should see that how many A's do we have here? How many A's do we have here? For example, I have one A here, one A, three A's here. How many B's I have here? How many B's I have here? For example, I have two B's here and zero B's here, and so on. I should see that how many of each character I have. There are 26 lowercase English letters. I have to see that how many of each one of them I do have, and I should compare them. I know that at the end they should be equal. I mean, the only way that their sorted version, the sorted version of them is equal if and only if I have the same number of each character. So occurrences of every character is the same. So that's when I can say that the sorted version of them is equal. So now the question is that what is the minimum number of steps in order to make them equal? How can I find that from each character? How many of that character I have in A and how many of that character I have in B? I have to calculate that. And in order to calculate that, I just use prefix sums. If you need to learn more about prefix sums, maybe it's good if I send you the video I prepared for prefix sums. Let me find it. Yeah. So if you want, you can watch this video about prefix sums. It tells you everything about prefix sum. I won't repeat it here. So the point is that from each character you have 26 characters. You have 26 English characters for each one of them and for each of the strings. So you have two strings and 26 characters. For each of them you make a prefix sum. So it's like you have an array of prefix sums of size 2 by 26 by n, the length of the sequences, and in which you will calculate that in each prefix how many of each letter do you have. So in this prefix, how many A's do you have, how many B's do you have, how many C's do you have, and if you do that, then when you consider an interval, you can just see that how many of that character you have in here and subtract from it how many of that character you have in here. Okay, you can consider these two values and subtract them with each other, and then you're gonna have all the characters that you have in the middle. So what you can do is that you can compare these two values in two strings. When you have some L and R, you can consider L and R in these two strings and compare that from each character. How many of them do you have? And just sum up their differences. Okay. Sum up their differences, and at the end you have to divide sum by 2 and report that as your final answer. Why you have to divide sum by 2? Because each time that you change a character to another, it's like you choose a character that you have more of it. For example, you have x1 of it and in A, and in B you have x2 of it, and turn it into, and you know that x2 is x1 is greater than x2, and you are turning it into another character that you have less of it. So you have y1 of it, but the other character, the other string b has y2 of it. By doing this, x1 will be subtracted by 1 and y1 will be added by 1. So it's like that the sum of these differences will be better by 2. I mean, you reduced the difference in 2 places. So at the end you have to see that what is this sum and divide it by 2 and report it as your answer. Do you need an example? Do you want me to show you an example or just jump to code? I mean, is it clear or is it better if I take an example? So, okay, sure. Let me talk about an example. So, consider this one. Consider this case. I have A, B, C, D, E, and E, D, C, B, C, B, A. Let me write it in here and jump to tablet. A, B, C, D, E, and E, D, C, B, A. And for example, you are considering the whole interval. For example, consider the first query when you have 1 to 5. So, in here, how many A's do you have? In here, how many A's do you have in here? We have 5 characters, so I just ignore all the other 21 lowercase English letters. Consider A, B, C, D, and E. Okay, so we have all these characters A, B, C, D, and E. You have to see that how many of them do you have in A, how many of it do you have in B. You know that we have, if you see, you have 1 A in A, 1 A in B, so it's 1, 1. About B's, we have 1B here, 1B here, so it's 1. About C's as well, 1, 1. About D's is 1, 1. And about E's is 1, 1 as well. So if you consider the differences, they will sum up to 0. So in this case, when they are completely equal, I mean from each number, each character, you have equal number of them, the answer is 0. We don't need to change anything. You have equal number of them, so if you sort them, they will be exactly the same. So this case, the answer would be 0. And as you can see, for this case, the answer is 0. But if we consider the second case, when we consider all the numbers from 1 to 4, all the characters from index 1 to 4, how would everything change? If we consider from 1 to 4, then I will have 1 less A's in the second one and 1 less E's in the first one. So in that case, this would be 0, this would be 0, this would be 0 as well. So by doing this, my differences, my sum of differences, I mean in here the differences is 0. About B, C, and D, there's no argument, there's no differences. But about A and E, the difference is 1. The absolute difference of these differences of these two values is 1. So the difference is 1, and I know that in each operation I can reduce the differences by 2. Because I can take one that is greater in A and take one that is less in A. Reduce this by 1 and increase it by 1. For example, in here, I can take this A and turn it into E. Then I will have 1 less A's, this turns into 0, and 1 more E's. And these two differences will become 0 as well. So I need to see that what is my sum, what is the sum of these differences, and whatever it was, I will divide it by 2, because each time I can make it better by 2. Each time I can pick one of them that is greater and pick one of them that is smaller in A, the number of occurrences, and I reduce this by 1, increase this one by 1. So I make them, I make the difference less by 2. So at the end, my answer is gonna be sum over 2. There were other ways to say that as well. You could also only consider the indices that the value of A is greater than B and only calculate the sum of those. Or the ones that only B is greater than A and only calculate the sum of those. Or you can calculate all of them and divide it by 2. All of them would work. So anyway, at the end, what I'm saying is that you need to consider this sum and divided by 2, and that is going to be your final answer. Does it make sense? Now I'm with an example. If it is, then we will jump into code as well. So this is going to be how we consider the how we can calculate the final answer. Do you have Discord? Yes. If you check the description of this video, you can find the link of Telegram and Discord. And guys, I really encourage you to join our Discord and Telegram channel. Let me send you the link of the Telegram channel. It is already pinned, I think. But let me maybe send the link of the Telegram channel. And also, if you want to support us, you can support us by liking the video or subscribing to the channel if you really like the video. There's no force for doing that, but if you really like the video, we would appreciate it if you like the video here. That would help for my work to become better and better. And if you want to join the Telegram channel, you can come here. And if you want to join the Discord server, you can come here. Okay, so is it clear? Shall we talk about the code now? So the point is that by using prefix sums, we can see that in this interval how many of each character you have. For example, consider character a random character, like character F. Okay, consider character F. You see that how many F's you have in this prefix, you have pre-calculated that. How many F's you have in here. You will subtract those values from this value. Let me use another color. From this prefix, you are subtracting this prefix, so you will end up with this interval. And you have that how many occurrences of each character there is in this interval. And then you compare it into your two strings and you calculate the sum and you divide it by 2, and that's going to be your final answer. So let me also show you the code to make sure that everything is now sound and clear. I will explain it on the code. So as I said, we have this prefix array, as I showed you in the tablets. We have this prefix array. It is of size 2 because we have 2 strings. 26 because we have 26 characters, 26 lowercase English letters, and n because we have n prefixes. Okay, so we have this. So I have defined this prefix and I have 2 strings. I show A and B with s of 0 and s of 1. So we seen s0, s1, and we have a 4t on 0 and 1. By the way, you can, when you want to have a 4 on a small set of a small size, for example, only 0 and 1, you can do your 4 like this, 4t on the set of 0 and 1. And then C from 0 to 26, and I from 0 to n, you could just say that pref of t and c and i plus 1 is equal to pref of t and c and i plus s of t and i minus a equal to c. So this way you have the prefix sums array. And then when you see in L and R, first you say L minus minus. You just say this in order to make your interval from 1 based and inclusive to 0 based and inclusive exclusive. Then everything would be cleaner this way. You have a 4c from 0 to 26, and you just say that num1 is equal to pref of 0 and c and 1 minus pref of 0 and c and L, and the same for num2. So you have num1 is that how many c's you have in the first interval, in the first string. Num2 says that how many of that character you have in the second one, in the second string. And you say that tot plus equal to tot stands for total. It's your total sum. Plus equal to a absolute value of num1 minus num2, and at the end see out tot divided by 2. And if you do this, if you just calculate these differences of the occurrences of the characters and divide that by 2, that is going to be your answer, and this way you're going to get an accepted verdict. So, does it make sense? If you are completely okay with that, please again use this emoji, or just put a plus in the chat, or if you need the explanation, just tell me to explain it again. Awesome. So let's move on to problem D then. Problem D. Let's wait till it loads. Okay. Given two integers n and x, find the number of triplets a, b, c of positive integers such that ab plus ac plus bc is less than or equal to n, and a plus b plus c is less than or equal to x. Note that order matters, and 1, 1, 2 is different to 1, 2, 1. So what we want in here is we have two numbers n and x. We want to find three numbers a, b, and c such that ab plus bc plus ca is less than or equal to n, and a plus b plus c is less than or equal to x. And we know that n and x are up to 10 to the 6th. So the first idea that comes to your mind can be like this, can be using a brute force. And by using a brute force, you can have 3 force. So I'm first just saying some idea with bad time complexity. So I'm just saying that let's have a 4 on A from 1 to 10 to the 6th. Then let's have a 4 on B from 1 to 10 to the 6th. Or I could say from 1 to n as well. But let's say 1 to 10 to the 6th. And then I have 4c from 1 to 10 to the 6th. So as I said, each one of them could be n instead of 10 to the 6th, because obviously you cannot use a number greater than n. You cannot also use a number greater than x. So only using 1 to n or 1 to x would be enough as well. So anyway, you have 3 fours, and you just check if check of a, b, c was true. Or in other words, it was possible, I mean, the a plus b plus c was less than or equal to x, and ab plus bc plus ca was less than or equal to n, just say c and t plus plus. And at the end, c of c and t. So this gives us an O of n cubed solution. Do you agree with this? So we already have an O of n cubed solution. This is very bad. Its time complexity is very bad because it's 10 to the power of 18. We have 10 to the power of 6 cubed. So it's 10 to the power of 18, which is a lot. And it's not good at all. But it's a solution with a bad time complexity. We will talk about how to optimize it. But do you agree so far with this solution? If you are okay with that, please again use this emoji. So now, oh my god. Let's see. Okay, so now let's optimize. We want to optimize it now. What is the first idea that comes to your mind in order to optimize this? What is the first thing that comes to your mind? Can anyone share ideas? Why do the audience ask me if I have a girlfriend? How is that important? It's not the first time. Okay. Yes, exactly. Exactly. So, C, you can avoid having this 4 on C. You can remove this. Why? Because C can be uniquely determined when you fix A and B. So you can say that you can have for A from 1 to 10 to the power of 6, and for B 1 to, let's use n because we used n there. So have a for A from 1 to n, B from 1 to n, and then you can just set C as x minus A minus B. So you don't have a third for, you don't need to have a third for C. You can just say that C is equal to x minus A minus B, right? So by doing this, we have optimized our solution and improved it to O of n squared. It's not good yet. It is still around 10 to the 12. So it's not still very good, but we reduced it by a factor of n. Is it clear? To optimize this, you need to know if I have a girlfriend or not. I see. Okay. So it is O of n squared now. Is it clear? I think maybe nobody is listening to the solution now. So if you are okay with that, please use this emoji. Okay, if you want, if you really are curious, I can tell you what's that at the end of the live stream. So I can answer that at the end of the live stream. For now, let's focus on the problem. Okay. So now we have optimized it to 10 to the 12th. So now let's optimize further. We want to make it even faster. How can we optimize it even faster? Optimize it even more. So we want to make it even faster. Do you have any ideas what we can do? How we can optimize it? How we can again make it better? So we did something about C. We said that we do not need this for C. So we now need to do something else as well to improve it further. Awesome, exactly. The point is that, you know, let me see if I can copy and paste this. Okay, so we had this force, right? The point is that that was a very good idea for optimization. We can just say that this 4 on B can be up to n over A instead of n. Why it can be up to n over A? Because if it is greater than that, AB already is greater than n. So there's no way that AB plus A plus BC plus CA is less than or equal to n. So the main idea is that not only C can be uniquely determined based on A and B, but also about B, we can say something according to the value of A. About B, we are sure that it cannot be greater than NA. We are sure that B must be less than or equal to NA. So we have these three forces. First we have A from 1 to n, B from 1 to n over A, and C equal to x minus A plus B, and then we will check. We will check if these values are okay. We will multiply them and we see that if AB plus BC plus CA is less than or equal to n or not, and also we check if A plus B, the second case is always okay. We just need to make sure that C is a positive integer. Do not forget that C cannot be negative. So this value should be positive. C should be positive. And if check was true, we just say C and C plus plus. Now the question is that, okay, yes, we can do this, but what is the time complexity now? Okay, what is the time complexity now if we do this? The point is that when A, when the value of A is 1, there is going to be n different values for B. When a is 1, there are n different values for b, from 1 to n. When a is 2, there is going to be only n half different values for b. When a is 3, there is going to be n third different values for b. When a is 4, there is going to be n fourth different values for b. So the point is that these two 4s in total are going to be n plus n half plus n third plus n fourth and so on. So it's like n times 1 over 1 plus 1 over 2 plus 1 over 3, 1/3, 1/4, and so on to 1 over n. Okay, so the question is now that, okay, what is this? So this is our new time complexity. Our time complexity is not now n squared, because for each value of a, there is not n values for b. So it's not n plus n plus n plus n, n n's, n times n. Instead, it is n plus n half plus n third plus n fourth. So it's n times this. And this value can be shown to be small. The name of this is h of n, harmonic number of n. And it can be shown that it is from theta of n log n. In other words, it is of O of n log n. If you're not familiar with what theta is. Theta is something more strict than O. So if it is from theta of something, it's also from O of that. So h of n can be shown to be from, sorry, not n log n, I'm sorry, log n. When it is multiplied by n, it's gonna be log n log n. Okay, so it's from theta of log n or O of log n. When it is multiplied by n, it's gonna be n log n. Why? If you want, maybe I can someday make a video explain it, harmonic numbers and why they are of order of log n. But if you want me to tell you a sneak peek of that, if you want me to tell you a summary, it's like this, you know, 1 over 1 plus 1 over 2 plus 1 over 3. I mean, I just want to give you some intuition that's why it is around log n. You know, the point is that if you keep writing these numbers, you know that 1 over 1 is 1. So it's at most 1. 1 over 2 plus 1 over 3, there are two numbers, each one of them are at most 1/2, right? There are two numbers, each are at most 1/2. So it's like at most 2 times 1/2. It's at most 2 times 1/2, which is 1. So it's at most 1. 1/4, 1/5, 1/6, and 1/7, there are 4 numbers, each are up to 1/4. Okay, so it's like at most they are 4 times 1/4. So it is 1 at most. And again, from 1/8 to 1/15, they are at most 1. So you're gonna have log n blocks, each at most 1. Therefore, this value, harmonic number of n, is at most log of n once. Log of n once, so h of n is gonna be at most log n. There's also another proof, another similar proof that shows that h of n is also at least log of n half. Log of n half. That is very similar to it. It just changed a little bit, like this. The blocks will be changed like this. This will be my first block. This will be my second block. This will be my third block, my fourth block. And the point is, for example, in this block, we have 4 numbers, each at least 1/8. So this block is at least 1/2. This block, we have 2 numbers, each at least 1/4. So this block is at least 1/2. Again, this block is at least 1/2. And this block is 1, so it is at least 1/2. So we have log n blocks, each are at least 1/2. So it also h of n is at least log n half. So basically, all I'm saying is that h of n is of theta of log n. Therefore, this is going to be n log n. Therefore, we have solved the problem. We have optimized it. to theta of, or O of the total solution is optimized to O of n log n. And if you implement it, you're gonna sound gone. If you implement it, you're gonna get accepted. Let me also explain the code to you. Okay, as you can see in this code, this is the whole code. You know, all of it is this. It's all of it. So you see in n and x, n is 0 initially. If you have a for a from 1 to n, then have a for on b. B is from 1 up to n over a. Or I have written it like this, up to where a times b should be less than or equal to n. It is equivalent to writing that b is less than or equal to n over a. So b is 1, I will continue till a times b is less than or equal to n, b plus plus. And most of times, guys, writing it like this is better. I mean, there's a reason that I write it like this. In this problem, there's no difference, but most of times it's better to use product instead of division. Most of times. There are some rare cases that division is better when we're dealing with overflow. But most of times, because division can be a bit problematic, it's better to just write what you want. I want a times b to be at most n. So I just write it. I want a times b to be at most n. B plus plus, and I calculate the upper bound for c. My ub or upper bound is equal to minimum of n minus ab over a plus b and x minus a minus b. So why do I say that? Let me also tell you that why it does it stand for. I'm saying that this value is the maximum possible value for c. Why do I say that? Why do I say that that is the maximum possible value for c? Because I know that ab plus bc plus ca should be less than or equal to n. So I know that bc plus ca which is equal to c times a plus b, should be less than or equal to, okay, my light is gone, very good. This should be at most n minus ab, right? So c must be at most equal to n minus ab over a plus b. On the other hand, I know that a plus b plus c is at most x. So c must be at most x minus a minus b. So c is at most minimum of these values, these two values. Upper bound for c is minimum of these two values. N minus ab over a plus b and also n minus a minus b. This is the maximum value that it can have, so I call it the upper bound for c. And if upper bound was greater than or equal to 1, I will add that by that much. Yeah, light is gone for now. So is it clear? I will fix the lights now. So just let's make sure if everything is clear. Let me for a second. Okay, is it clear? Move down. What do you mean? So let me get back to my code. I just said that upper bound is equal to minimum of these two values if upper bound was at least 1, because I know that c should be positive. If upper bound was at least 1 and plus equal to upper bound, the upper bound. I don't know if it is possible on often. I don't think so. I think that it's the best possible way. Maybe for some algebra you can also find, I don't know, some straightforward formula for it. I don't know, I haven't thought about it, but I think for here it can be solved like this. Okay. You really need to know. Okay, so let me turn on the light again for a second. So sorry for that. Let me, sorry. I'm trying to first pause this stream, but it doesn't work as well. Okay, I found the way. Okay, I'll come back in a second with the lights on again. Okay guys, can you hear me? The light is on again. So, awesome. Just let me make sure that. Okay, awesome. So, let me, sorry for the big display. Okay, so let's move on to the next problem, problem D, if this one is clear. So, let's move on to problem E. So, this problem states that, oh my god, this is messed up. Okay, this is not good. Okay, so So it says that you want to obtain your favorite character, and what you want to do is this: for each pair of integers L and R, basically you just want to count the number of pairs X and Y such that X and Y is completely inside L and R, and the amount of zeros is equal to the amount of ones in this substring. You have to say that how many ways do we have for that. Okay, so let's move on to the tablet and talk about this. Sorry. Okay, so what we can say in here, we want that for every L and R, we want to calculate that how many X and Y's are inside it such that the number of zeros and ones are equal in this interval. So the number of zeros is equal to the number of ones. So the point is that if we want them to be equal, if we want the number of zeros to be equal to the number of ones in an interval, sorry for this, then we need to make sure that it's like if we make another array for prefix sums again, so yet again we're gonna need to use prefix sums in here. If we make an array out of it, wherever we see 0 in our string, we write 1 there, and wherever we see 1, we write -1 there. Okay, so we make another array out of our array, and wherever there is a 0 in our array, we write a 1 here, there, and wherever there is a 1, we write -1 there. So the point is that the sum of this interval should be equal to 0. The sum of this interval should be equal to 0 in that array. And if the sum is going to be 0, it means that this prefix must be equal to this prefix. The sum of this prefix and this prefix must be equal. Okay. So from now on, I know that this prefix is equal to this prefix. Okay. I can't believe the funny comments. Okay. So these two must be equal in the prefix sums array. So now the point is that instead of calculating the good X and Y's for each L and R, calculating the good X and Y's, let's for each X and Y calculate the good L and R's. Anyway, we want to count the number of tuples of L, X, Y, R. We want the number of these. So instead of for each L and R, see that how many X and Y's will work. Oh my god, light is gone again. Let's forget about it. Instead of this, let's try to find out that for each X and Y, how many L and R work for it. So for each X and Y, try to find out how many L and R's exist, such that X and Y is inside that interval, and we are sure that prefix of Y is equal to prefix of X. And we are assuming that XY is an inclusive exclusive interval, so that this is exactly Y and X that we're comparing. Okay, so this is what we want to calculate. This is what we want to make sure about. So we want to find for each pairs of X and Y such that their prefix sum is equal. We want to see that how many L and R's work for them. So if this is X and Y, how many L and R's would work for it? The number of L and R's is going to be, the L should be before this X. So L can be anywhere in here. This is the places that L can be it. And R can be anywhere in here. So these are the places R can be. So if assume that X and Y are zero-based indexed and inclusive exclusive, so it has Lx but it does not have a Y itself, then the number of possible L's is going to be X plus 1. The number of possible R's is going to be N plus 1 minus Y. So for each such X and Y, we need to calculate X plus 1 times N plus 1 minus Y. We need to sum up these values. Okay. Do you agree with this so far? So I'm saying that for each X and Y that we have prefix of X equal to prefix of Y, for each such X and Y we need to sum this up. If you are okay, put this emoji please. Okay, I explain it once again. Sure. I'm saying that instead of, the first idea is this, instead of calculating all the good X and Y's for each L and R, calculating all the good X and Y's, try to calculate L and R's for each X and Y. So at the end of the day, you want the values of these tuples of L, X, Y, R, right? So instead of fixing L and R and for each L and R finding the good X and Y's, let's fix X and Y, and for each X and Y find the good values for L and R. And what is the condition that X and Y must have? If we are talking about the interval, the inclusive exclusive interval from X to Y, we need to have that prefix of X must be equal to prefix of Y. We must have this, right? We must have that prefix of X is equal to prefix of Y. Because this means that the sum in this interval is 0. And do not forget that I first constructed an array out of my string. Whenever I had 0, I've written 1 instead. Whenever I had 1, I write minus 1 instead. So I said that if the number of zeros and ones are equal, it means that the sum here should be the same. If the sum here should be 0, if the sum here is 0, it means that the sum of this prefix is equal to the sum of this prefix. So the prefix from to Y should be equal to the prefix to X. These two must be equal. This is the only condition that we have for X and Y. The sum of this prefix, I mean, for example, let me take an example. So consider the last example, the last input. We have 1, 1, 0, 0, 0, 6 zeros. This is the last example in the problem statements. So first of all, I make an array out of it. This is my string. I make an array out of it. How do I make an array out of it? I say that this is gonna be equal to, how do I make an array out of it? I say that for whenever I had 1, I write minus 1. Or I could, instead of 1s, I could also write 1, and instead of 0s, write minus 1. That would both work, there's no problem. Because 0 and 1s are just labels here. There are some labels that want them equal. Their value is not important. They are just some signs, some labels. So instead of 1s, I write minus 1. Instead of 0s, I write 1. Okay. So this is how I can make my array. And I'm saying that an interval is good, the number of zeros and ones are equal. For example, this interval is good if and only if the prefix sums are equal. So if you calculate the prefix sums until, assume that we consider the prefix sum before each element. The prefix sum before this element is 0. This is before this element, so this -1 is not included. It is not inclusive, it's exclusive. To this one is -1. To this one is -2. Let me change the color because this is not very clear. Let me change the color. So till here prefix sum is 0, -1, -2, -1, 0, 1, 2, 3, 4, 3, 2. These are going to be, and the last one is also 1. This is going to be our prefix sum, and I'm saying that this interval is good. This interval is from index 1 to index 3, inclusive, exclusive. If and only if prefix of 1 is equal to prefix of 3. Because we know that the sum of here should be 0 if this is good. The sum of here should be 0, must be 0. When the sum of here is 0, when this prefix before these elements, so which is going to be the sum of these elements, is equal to this prefix before these elements. So these two must be equal. When these two are equal, we are sure that the values are gonna be 0 in the middle. So we need to make sure that prefix of x is going to be equal to prefix of y, because it means that the sum from x to y is 0, which means that the number of zeros and ones are equal in that interval in our string. Is it clear now? Awesome. If you understood it, if you put a plus or use the emoji or anything, would work. And if it is not clear, tell me to re-explain it in parts. So, awesome. So x and y need to have this situation. Now, for each good x and y, let's talk about a bad time complexity again. So let's consider that we have a bad time complexity. Assume that we have fixed x and y. So we have two 4s, 1 4 for x from, for example, 0 to n minus 1, for example, or let's do not get into details. X from 0 to n and some y from x to n. Assume that we have fixed it and we checked that prefix of x is equal to prefix of y. This is, we are considering this inclusive exclusive interval, and we've seen that prefix of x is equal to prefix of y, prefix sum of y. If this happens, what I can say is that I want to count how many L and R's are good. Count the number of L and R's in here. How many L and R's are good? I say that when you fix the values of x and y, for example, x is here, y is here, my L must be before this x, at this x or before that. My y must be at this y or after that. So how many good L's do I have? The number of good L's is going to be x plus 1, because everything from 0 to x itself are good. Everything from 0 to x itself are good. The number of them is going to be x plus 1. And for this R, everything from y to n are good. Okay, so in here, everything from 0 to x are good for L. L is in this interval. And in here, R can be from the interval from y to n. So there are x plus 1 choices for L and n minus x plus n minus y plus 1 choices for R. X plus 1 choices for L, n minus y plus 1 choices for R. And I will multiply these two numbers. So if this happens, I say that ans plus equal to x plus 1 times n minus y plus 1. And that's going to be all. So right now I have an O of n squared solution, which is not still good time-wise, but this is a solution that I have. Do you agree with this? Why would there not? Why there wouldn't be any overlap? Because for each x and y, I'm just considering all the good L and R. So each case will be counted only once, if you mean that, if you're concerning about overcounting. So for each x and y, I want to count the number of good tuples like x, L, x, y, R. So I fix L and R and I see that how many L and R's are good for them. I know that L must be from 0 to x and R must be from y to n. So the number of cases for L is x plus 1. The number of ways for R is n minus y plus 1. So when I fix x and y, even I find an x, the values of x and y that work, I should multiply these two values. Okay, and for each x and y, I will multiply these two, and that is gonna give me the final answer. Is it clear now? Do you have any other examples? Any other questions? Or do you need any more examples? For now, I just have introduced an O of n squared solution. We're gonna talk about how to optimize it, but for now, let's assume that we have a 4 on x and a 4 on y. Okay, so right now our solution is n squared. I have a 4 on x, 4 on y, and then I say that if x and y were okay, or in other words, prefix sum of x was equal to prefix sum of y, if that happens, then just do this. Multiply x plus 1 by n minus y plus 1. Add that to ans. Okay? Because L can be also equal to x. The point is that, for example, assume that x is 1. And we are talking about 1-based indexing. Assume that x is 1. And we are talking about 1-based indexing. So it means that x is the second element. The point is that we have two ways for L. Either it starts from before the element number 0, or it starts from the element before the element number 1. So it has x plus 1 choices. It can be before 0, it can start before 0, it can start before 1, it can start before 2. The first index from L to R can be 0, can be 1, can be 2, can be 3, and can be x. So it can be anything from 0 to x. So it has x plus 1 choices. And about y, wherever y is, the end can be anywhere after. The end can be anywhere after it, because the interval from x to y is inclusive, exclusive. It doesn't have y. My R can be here. It can be before y, before y, before y plus 1, before y plus 2, before n minus 1, and after n minus 1, or we can say before n. So we have n minus y plus 1 choices. N minus y choices because it can be before y plus 1, 2, before n minus 1, and one other choice that it is at the end of the array, after even the last one. So it's gonna be n minus y plus 1 choices. So I should multiply x plus 1 by n minus y plus 1. We are considering 0, so we are considering y. For now we have two force for x and y, and then I'm just trying to fix that, find that how many L and R's work. And I know that L's can be from 0 to x, R's can be from y to n minus 1. Is it clear? Was this your question, or did I answer it? Y prefix of x equal to prefix of y gives a solution, because as I said, if prefix of x is equal to prefix of y, it means that this prefix has equal sum to this prefix. When they have equal sum, it means that this period has some 0. So when it has some 0, it means that in our string there was equal number of zeros and ones, because we know that in here for each 0 we put 1, for each 1 we put -1. So if the sum of an interval is 0, it means that we have equal zeros and ones. And when we have equal zeros and ones, we know that this x and y works, so we need to just count that how many r's work here and how many l's work here, and that's going to be all. Okay, is it clear so far? If it is clear, we can talk about optimization. If you have any other questions, you feel free to ask. Awesome. Awesome. So now that we know this, now the question is, okay, how to optimize it? So again, we're back to optimization. Optimize. So how can we optimize it? Well, the point is that when you reach some y, instead of again having 4 on all the previous x's, if I can have an array of total sum, you know, I know that for each x that has prefix sum equal to prefix sum of y, assume that prefix sum of y is equal to some value like, I don't know, like b. Okay, so assume that this prefix sum is b or p. P is better, makes more sense. So let's say that it is p. The sum of this prefix sum is p. So we want all the x's such that their prefix sum is also p, right? So we want all the x's here that their sum is also p, and we want to add up their indices plus 1. Okay, when we want to add it by x plus 1, we can have some value total sum of p such that for each p, we know that for all the indices, such that their prefix sum is some p, what is the sum of their indices plus 1? So I mean that after I worked on y, so I have a for y from 0 to n minus 1, for example, I know that it's the prefix sum of y is p. Sorry. Okay. So we know that, I don't know why it crashed, but anyway, we know that it is equal to this. Int of p is equal to prefix of y. So what I can say is that in here, I can just focus on all the prefixes before that their prefix sum is also p. And I can, if I have what is the sum of their values of x plus 1, I can simply just multiply n minus y plus 1 by that sum. I mean, if I already know that what is the sum of their indices plus 1, L and R are not good. I mean, X and Y were good. X and Y, if prefix of X is equal to prefix of Y, then X and Y are good. And then we need to just find a value of L before this X and the value of R back after that Y. So that's going to be all. So L and R just need to be before this X and after that Y. So there's nothing to be good or bad about them. It's only the fact that they need to be before this X and after this Y. For before this X, there are X plus 1 choices. For after this Y is N minus Y plus 1 choices. Okay. So if some X and Y are good, I need to multiply these two numbers for L and R. and sum them up. So now the question is that instead of multiplying n minus y plus 1 by each one of these x plus 1s individually, let's just know that what is the sum of these x plus 1 and only once multiply that sum by this value. So if I know that what is the sum of all the x's such that the prefix of x is equal to p, I can multiply that sum by this value of y. So what I can say is that if I know this sum, I can multiply it by that sum and add that value to n's and then update these sums later on. So I can just say that instead of what I have here, I can just say that n's plus equal to n minus y plus 1 times the total sum of p, what I have stored, the sum of indices plus 1 for that p, and then I will update total sum of p. Because y itself has this prefix sum of p, I should add y plus 1 to it. So the point is that what I can say is that for each y from 0 to n minus 1, I see that what is this prefix sum, and then I say that I know that what is already the sum of indices plus 1 for the previous ones that have the same prefix. I just multiply n minus y plus 1 by that total sum, and then I will update this total sum by this value of y plus 1. So the point is that in total sum, I know that sum of all those x plus 1s, instead of individually multiplying them by n minus y plus 1, instead of individually doing that, I store that what is the sum of them, and I only once multiply that sum by n minus y plus 1. Right? And this way I can calculate the final answer easier. So all I can do is to keep this total sum, and when I kept this total sum, I can just, when I know this total sum, I can just multiply this by n minus y plus 1, and then I will update this value of total sum. Yes, exactly. For each y, now my 4 is only on y. I only have a 4 on y, and I calculate all the good x's, l's, and r's for this y. I know that an x is something, a good x is something that comes before y, and prefix of x is equal to prefix sum of x is equal to prefix sum of y. So I know that I should search between among those who their value of prefix is equal to p. I know that for all of them that the value of their prefix sum is equal to p. I have calculated the indices plus 1. I have summed up their indices plus 1, and all I can say is just multiply that value by n minus y plus 1. Because instead of individually having another 4, you know, in here, in this solution, I had another 4 on x. I'm saying that, okay, let's remove it. When you have a 4 on y, let's just focus on all the things before y that have the same prefix sum before it, and multiply those values, those sum by this value. And this way you can get the final answer. How does summing all x? Well, the point is that I do not have a 4 on all the x's anymore. I have removed a 4. I mean, if you want to know that how that does that optimize it, I used to have a 4 here for every x, and I had a 4, and for each x I was checking if it matches with y is prefix sum, and if it was, I would multiply them. Now I'm saying that instead of having 4 on all such x's and 1 by y, multiplying them by n minus y minus plus 1, let's see that what is the sum of all of them. Let's calculate the sum of all of them, and only once multiply that sum by n minus y plus 1. So do it just once. So instead of having a 4 on all the previous elements, in O of 1 I just multiply it by a single value. So I just keep that what is the total sum of them, all the values that such that their prefix sum is sum p, and I just add this value to my add the product of this value and n minus y plus 1 to my final answer. Is total sum a map? No. Total sum, you can easily see that for total sum, the values inside it is from minus n to n, right? The values inside it is from minus n to n, because there are n elements at most. Each one of them are 1 or minus 1. So the sum of a prefix is either 1 or minus 1. So I can just have an array of length 2n. I'll show it to you in code. 2n, and whatever, for example, if I want to access some index x, I can just work with x plus n. For example, if I want total sum of minus 1, because minus 1 is out of bounds. You know, in here I have negative numbers, and negative numbers are out of bounds. So if I cannot easily define array for that. But instead, if I add n to all the indices, all of them will become positive. All of them will become from 0 to 2n. So by doing that, if I want to look up for minus 1, total sum of minus 1, I just look for total sum of minus 1 plus n, or n minus 1. So you can do this. Yeah, sure. So let's move on to the code. So I can say in my code that, again, the code is very easy and simple. As you can see, first of all, I have this total sum, and I defined n to be at least 4e5. I defined n to be at most 4e5. This is because of that multiplying by 2. N is at most 2e5. But as I said, this array of total sum must be of size 2n. So I multiplied n by 2, the max limit by n by 2. I could instead just write 2e5 in here, and I multiply 2 here. I could define total sum, the size of this total sum, to be 2n. But there's no significant difference. And then I just say that I have a 4 from 0 to n, and I calculate all the prefix sums, as you can see. If it is 0, I put 1. If it is 1, I put minus 1. And then I have a 4 from 0 to n, and I add to ans n minus I plus 1. This is my y. I is my y. So I'm adding n minus I plus 1 times the total sum of all the values that have the same prefix sum. Total sum of n half, n is 4e5. So it's like I'm adding it to the middle point so that I'm sure that everything is from 0 to n, to max n. I'm adding n half to it, and I know that this is twice of the needed size. So if I go in both directions, I won't go out of bounds. So I just look for total sum of n half plus pref of I modulo mod. And then I say that total sum of n half plus pref of I plus equal to I plus 1 afterwards, after I did this. And this modulo equal mod is just in order to make sure that we are calculating everything modulo mod. So after doing each operation, I say that modulo equal to mod. And I defined, for this problem, I defined everything, every int as long. So everything is in long in here. And at the end, when I'm done with this, I have a 4 from minus n to n, and I set total sum of n half plus I equal to 0. Because I'm done with them, I want to reset these values for the next test case. Does this make sense? Is it clear? If you're okay with that, please again use these emojis or chats or anything. And if you have any questions about any part, just feel free to tell me about that. Awesome. That is awesome. Awesome. So let's move on to the next problem. Okay, problem F now. Okay, problem F. So it says that you are given two arrays A and B of length n. Initially your score is 0. In one operation you can choose an integer I and add AI to your score. Then you must set A sub I equal to maximum of 0 and A sub I minus B sub I. You only have time to perform K operations before a sparkle sets off a nuclear bomb. And what is the maximum score you can acquire after K operations? Okay, so we know that each time we can choose a number and when AI and add that to our score, but after doing that operation it has some effect that AI will be subtracted by BI, will become equal to maximum of 0 and AI minus BI. So what I will do in here is this. Okay, I think that this is great. What's happening is great. Okay, so for problem F, we just say that I set a threshold. You know, first of all, I say it again, a bad time complexity algorithm. I just say that, first of all, assume that we just do a greedy brute force algorithm. I say that it's always optimal to choose the maximum. So whatever your values of A's are, you can each time choose the maximum. So you can be sure that this will work well, because if you have a maximum number, if you do not choose it ever, you are just losing it. Why? You could at least choose it once and get the current maximum value. We know that everything else is worse than it. So if you never choose it, if you would remove one of the operations and instead choose that, your answer would be better. So we can say that the optimal solution is to keep choosing the maximum. So I have a greedy solution. I can say that each time choose the maximum. But it has, this will not have a good time complexity. Why? Because if I keep doing it, there are K operations and K is up to 10 to the 9th. That is a lot. I cannot do this 10 to the 9th times. So what I would do instead of that, so I have this bad time complexity solution, it can be like O of K log n. We can keep a set, for example, and each time just pick the maximum. But instead of that, I do something else. If I want to increase it, let us see that. Why? Let me for a second, sorry. The tablet is not responding well as well now. Okay, so I can say that what I would do is that I know that each time I can just simply choose the maximum value, and that is gonna give me the best possible answer. So I keep choosing the max value. But I know that that wouldn't work well always, because it's gonna take a lot of time. I need to do this operation K times, and each time will be of log n. So it's gonna be K log n, which is gonna be a lot, because K is too huge. K is all at most 10 to the 9th. So what I would do is this instead. Let's set a threshold. So I want to find out, I can say that when I do this greedy algorithm, there should exist some x such that x is gonna be the last value that I choose. I mean, I have several operations. Each time I choose another element. I choose another value and add that to my score. I know that this is in non-increasing order. This is in non-increasing order, right? these values are in non-increasing order, because as I said, each time we take the maximum, we know that each time we are using the maximum we have. If next time we pick a greater value, we can say that, okay, why in our previous term we didn't choose that. So I can say that in my last term, what was the value that I chose? Let's call that x. The point is that I can binary search on this x. I can find out what this value of x is. How? I can do binary search on each mid. I can say that how many operations I can do on my values such that these values keep being at least mid. So I can just have a binary search on these values and find out how many times I can do operations such that I only use values greater than or equal to mid. And the greatest mid such that the number of operations will be at least k for it is going to be my answer. So I need to make sure that I need to define a function get of x that tells me that if I only choose do the operations while my numbers are greater than or equal to x, how many operations can I have? How many operations can I have? Okay, so you can just simply calculate it by 4. We can have a 4I from 0 to n minus 1, and for each one of them you can see that how many times you can choose these indices. I know that my AI should be greater than or equal to x, so I can see that what is AI minus x. First of all, I can say that if AI was less than x, then it is 0. I can do no operations on this one because it is already less than x. Otherwise, if it is greater than x, I can say that what is, let's define d as AI minus x. So I can simply say that the number of operations that I can do on this element is going to be d over b sub I plus 1. Because each time this d will be decreased by b sub I. So the number of operations I can do till d is still positive is going to be d over bi plus 1. After this d over b sub I plus 1 operation, now it is going to be smaller than that value, and I cannot do any operation afterwards. So this way I can count that how many steps I can have on each element, and I can add them up. I can see that what is this total value. Then I will have that what is the total value of the operations, total number of operations that I can have. And if this was greater than or equal to k, then it means that my last x is greater than or equal to mid. Otherwise, my x is less than mid because I cannot do k operations and in all of them my number is greater than or equal to x. Does this make sense? So this is the first step. When I want to find such x, I can just say that for each one of the elements, when I find such x, it means that when x is my last operation, it means that all these operations are on numbers greater than or equal to x. Therefore, the number of times that I can do operations on these is on these numbers, such that the numbers at least x should be at least k. So when I sum up these values should be must be at least k. If you are okay with that, put a plus, otherwise put a minus, or tell me if any part is not clear. Okay, can you tell me that which part is not very clear? So basically what I'm doing so far is this. I have several numbers. I want to make sure that I know that in greedy algorithm, I know that each time I choose the maximum. Now when I have several numbers, I want to see that how far I can go such that all the operations I do are on numbers greater than or equal to x. Okay, x is my latest operation. My last operation is a number My last operation is on number x. Okay. So the last time that I choose the number, I see that it is x. So I want to find out that what is my last operation. What is the last number I choose? I want to find that out. Okay, so when my last operation is on number x, it means that all these operations are on numbers at least x. So I have to be able, so assume that I have a function get of x tells me that how many operations at most I can have so that all the numbers I choose, all the numbers I choose are at least x. All the numbers that I choose must be at least x. Okay, I want to make sure x is something that I have fixed. I want to make sure that all the numbers that I choose are greater than or equal to x. Okay, I want to make sure that all my operations are on numbers which are at least x. Okay, so I want to make x as great as possible. So, sorry. I want to make x as greatest as possible. So when I fix, I want to find maximum x such that all my operations are on numbers greater than or equal to x. So each time when I choose a number, it is at least x. And you will see that how that is helpful. So for now, let's just consider that I want to find such x. I want to find such x such that all the numbers that I choose will be at least x. Okay. Yes, Codeforces contests are not at good time for us either. For us is very soon in the morning. Yeah, but when I was back in Iran, it was in a very nice time. But now it is not in a good time. So anyway, I want to find maximum x such that all my operations are on numbers greater than or equal to x. So for each x, I have some get of x that tells me that how many times I can do an operation that my number is greater than or equal to x. The point is that if I find the maximum such x, I can be sure that all the numbers I choose are greater than or equal to x, but all the numbers I choose are not greater than or equal to x plus 1. Otherwise, that value instead of x would be x plus 1. I know that x is the maximum number that all my operations are greater than or equal to x. So it's not x plus 1. No. X must be as large as possible. So I want to find the greatest possible x, find maximum x, such that all my operations, when I choose a number, this number is always greater than or equal to x. Let me tell you an example. This way is better. So consider this first example: 3, 4, 5, 6, 7, and 2, 3, 4. Okay. So how many times I can choose a number if I want to make sure that all my numbers are at least 6? How many operations I want to have? If I only choose numbers if they are at least 6, how many times I can do operations at most? Can you say that in the chats? So for example, assume that I want to see get of 6. which means that how many times? If I only choose numbers as long as they are greater than or equal to 6, how many times I can choose numbers? Can anyone say that? Exactly, 2. Because once I can do operation on this 7 and it becomes 3 then, and once on this 6 and this one also becomes 3 then. So I can do just 2 operations. The next time my maximum is 5. I can not do any operation afterwards. Exactly. So get of 6 is 2. What about get of 5? What is get of 5? Can anyone say that? No, not same. Three, yes, it's 3. Because I can do an operation on this one, it becomes 3. This one becomes 3. This one also becomes 3. So I can do 3 operations. The next time I cannot do anything. So I can do on this 5 as well. Awesome. What about 4? What is get of 4? What is get of 4? If I want all the numbers I choose to be at least 4, how many operations I can have at most? Exactly, it's again 3, because I can choose this 7 first, then this 6, then this 5, and then I cannot do anything. But what is get of 3? What is get of 3? My numbers are 5, 6, 7. My AIs, my BIs are 2, 3, 4. So what is get of 3? Awesome, 6. Yes, it is 6. Why? I can do 6 operations if I want my number to be at least 3. First I do on this 7, it becomes 3. This is my first one. My second one is on this, and this one becomes 3. My third one is on this, and this one also becomes 3. Then the next one is on one of these 3's. There's no difference between them. This one, it becomes 1. The fourth operation is on this one. It becomes 0. And then on this one, it becomes 0 as well, because it's maximum of 0 and AI minus BI. So I can do 6 operations if I want my numbers to be at least 3. So the point is that now when you find this, I know that my k, get of 3 is 6. I know that my k is 4, right? My k is 4. So 3 is the maximum number such that get of 3 is 6. Is 6 and is at least 4. Is at least k. 3 is the first number, that get of 3 is at least k. But I know that get of 4 is not at least k. So if I do the greedy algorithm, I know that all of my operations are on numbers greater than or equal to x. But all my operations are not on numbers greater than or equal to x plus 1. Okay? Which means that one of my operations are on x itself. For example, here I do 4 operations. I know that if I do the greedy approach, in my first 6 operations, my numbers are at least 3. So when I do 4 operations, I'm sure that all these 4 operations are with numbers at least 3. But I'm sure that they are not all at least 4. Because I can only do 3 operations which their value is at most 4. This means that one of my operations must be on number 3 itself. So my last operation, because this is non-increasing, my last operation is on 3. So the point is, if you find the maximum such x, such that the number of operations that you can do on numbers greater than or equal to x is at this k, that is going to be your last operation. Your last operation is on such a number. Is it clear now? Is the definition of get clear, and what does it mean when we find the maximum x such that get of x is greater than or equal to k? So the whole point, yes, we want to find the maximal x which exceeds k operations, exactly, and that will be the last operations value. Yeah, so exactly, this comment is exactly what I'm trying to say. We try to find the maximal x which exceeds k operations, and that will be the last operations value. Exactly. So this way we will find the last operations value, and that's gonna help us a lot. Why? Because at the end I can see that, okay, how many operations I will have. I know that I should work with get of 3, so I will move on till my number is at most 3. Now I can say that assume, let's forget about k for a second, let's forget about k for a second and assume that we will continue till our numbers are at least x. Continue till our numbers are at least x. So in this example, let's forget about the fact that we will do the operation 4 times. Let's assume that we will keep doing the operation till my number is at least 3. Okay, till I can get a number that is at least 3, I will continue, not 4 steps. So when get of 3 is 6, get of 3 is 6. So we can say that I will continue 6 steps, not 4 steps. Then what is going to be my answer if I continue for 6 steps? What will be my final answer if I continue for 6 steps instead of 4 steps? I will continue as long as my final answer is at least 3. My numbers are going to be at least 3. Then what is going to be my final answer? This way if I continue. What is the value that I get? Can anyone say that? Exactly, 27. Because first I do on this 7, I choose this 7, this turns into 3. Then I choose this 6, this turns into 3. Then I choose this 5, this turns into 3. Then I choose this 3, it turns into 1. I choose this 3, it turns into 0. I choose this 3, it turns into 0. So my answer is going to be 7 plus 6 plus 5 plus 3 plus 3 plus 3, which is 27. Okay. So my number is going to be 27. But the point is that I don't want to do the operation 6 times. So now I know that I don't want to do the operation 6 times. I want to do it 4 times. So the point is that we showed that when we consider the first 4 operations, the 4th operation is on number 3. But also we know that there is some 5th and 6th operation as well. So there are 2 additional operations that I counted, but I should not count them. What do I know about those 2 operations? I know that their number is also at least 3, right? On the other hand, on the 4th operation, I choose number 3 because get of 4 is 3, right? Get of 4 is 3. So only in 3 steps I can choose numbers which are at least 4. And I know that all my numbers are at least 3. So these 2 exactly, these comments is exactly what I want to say. They must be 3 as well. So what I can say is that these two are also 3. So you've done 6 operations. You must have do 4 operations. You can simply decrease from your answer, subtract from 27 that you got, subtract these 2 additional operations that give you an additional 3. You don't want them. So at the end, you see that how many additional operations you had, you multiply them by your value, and you will subtract them, so you get 21. So your answer is going to be 21 because you have done 2 additional operations on 3's, and you are sure that those 2 additional numbers are on 3's. So you just need to subtract 2 3's from it, and you get 21 this way. And as you can see in here, the answer is really 21. So you see that how many times you can do the operation, and it is possible that get of x is greater than k. If it is greater than k, you just need to be that how many times it is greater than k, and subtract that from k and multiply it by the value of x, because that is the additional value that you calculated and you must not calculate. Okay, so this is what I can say about this. And this way you can find out the final answer. So I will implement some function named get, that it gets some x and tells me how many operations I can have with values at least x. Then I have another one, then when I want to calculate my final answer, I'll find the maximal x. Let's change these numbers to t because it is I don't want to confuse you with the same name for the characters. So get of t just tells you that how many operations we can have with values greater than or equal to t. Now I want to find the maximal x such that get of x is at least k. So get is defined for every value t. I find the maximal value x such that get of x is greater than or equal to k, and then I see that what is the answer that it gives me. And from that I can see that how many steps that it has chosen. I know that, for example, when I consider some ai, I have some ai and some bi. Assume that d is equal to ai minus that value of t. When I'm talking about get of t, I will consider ai minus t, and I say that the number of operations that I can have is equal to d divided by b sub I plus 1. Because the first time I can do the operation and I get ai, the first time I get ai, the second time I get ai minus bi, the third time I get ai minus 2bi, and the last time I get ai minus d over bi, floor of d over bi. So these are the numbers that I'll get. These are the numbers that I'll get, and I should add all of them to my total sum. So I have some number of operations. My number of operations will be added. Let's call it with total operations. Will be added by num, and my total sum will be added by this value. What is this value? This value is equal to this num times ai minus these subtracting values. We know that there are num sentences. Each one of them have some ai, and this subtracts that we have is 1 times bi plus 2 times bi plus 2d over bi times bi. Or by d over bi, I can say it is num minus 1 minus num minus 1 times bi. So I can say that it's the sum of numbers from 1 to num minus 1, which is going to be num times num minus 1 divided by 2 times bi. So this is the total sum, how I can obtain total sum, and this is then the total number of operations. And at the end, I should return, when I find the maximal x, that's get of x is greater than or equal to k, I should return for that specific x total sum minus total operations minus k, those additional operations that I should have not have, times x. For example, in my example, this total sum was 27. The sum of these operations was 27. But there was 2 additional operations that I should have not have them, and the value of x was 3. So from the total sum of 27, what was 27? It was the sum of 5 and 3 and 6 and 3 and 7 and 3 on my 3 numbers. But I know that I had 2 additional 3s that I should subtract them. So my final answer that I will return for that x is going to be 21, which is going to be my final answer. Does this make sense? If any part is unclear, tell me, otherwise maybe it's better if I just continue explaining it on my code. So that's the whole thing that I will have. So I have ai's and bi's, and I have this binary search. I get of mid. Get of mid dot first is exactly the value gets that I was talking about. Let's just consider the first attributes of get. So we want to find out get of mid dot first just tells me that how many number of operations I can have such that all the values are greater than or equal to mid. So what I say is this. I have a 4, as you can see, I have this total num, this is total number of operations, total sum is total sum. So for each one of them, I from 0 to n, I just say that for this difference is equal to ai minus this lower bound for that values that I want to choose and add to my score. And int of count is going to be difference, the difference over b sub I plus ai greater than or equal to lb. I mean, this just says that, I just add 1 if I can do the first operation. This is if I can do the first operation. And I also have diff over bi additional operations after that, if I can do the first operation. And then I say that total num will be added by count. This is the total number of operations that I can have. And then I say that sum is equal to ai times count minus 1 times count divided by 2. This is the number of times that I can do operations on bi's. And then I say that total sum plus equal to sum. And I say that if total num was greater than k, total sum, this so far, it was for calculating total num. I mean, this first is total num, the total number of operations that I can have. And then total sum also calculates that what is the sum of these operations. And when I want to, I will return pair of this total num and total sum. When I want to return total sum, I should just say that if total num was greater than k, you should subtract from it total num minus k times lower bounds. Because those are the additional things that we don't know. Total sum is only useful if total num is, if my input is only x. And you can use that, you can see that I use second only when I'm working with that maximal x. For the rest of them, it doesn't matter that what this value is. So just keep in mind, only for x it matters that what this number is. So I return total num and total sum. I find the greatest value for x, and I just see out get of low dot second, the total sum for that. I hope that it makes sense now. So let me know if it is okay. Awesome. Awesome. So let's move on. I'm glad that you understood it. Yes, it was a good problem. Let's move on the next problem, problem G now. Okay, for problem G, it says that we have a land and there exists n houses and n roads. We have some pairs that these pairs should have a path to each other. Initially, our graph is of form of a circle. 1 has an edge to 2, 2 has an edge to 3, and so on, and n has an edge to 1. We want these pairs to have a path among each other, and we want to find that what is the minimum number of rows that they must be maintained. So we want to get rid of as many rows as possible. So for problem G, first of all, I can say that I want to maximize the number of rows to get rid of. I want to eliminate rows as much as possible, right? First of all, I tell you that this maximum number of rows that we can get rid of is at least 1. There's always a way to get rid of at least 1 row. Why? Because in the worst case scenario, we have some A and B's, and I know that A is less than B. In the worst case scenario, I can just remove this additional edge between 1 and n, and everything is still okay. They can use this path, this straight path in here, these edges in here. So the answer, if our answer is the maximum number of rows that we can get rid of, this is at least 1. Okay, so we know that 1 row that at least we'll get rid of. We will get rid of. So we are sure what? No, I haven't seen RNG solution for you. No. So this is one thing that we are sure that at least one of them we will get rid of. The second important thing, if we fix that we're not going to use a road. If we fix that, okay, this road, I am not going to use it. The cycle turns into a path. So, and that is very useful. Why? Let me first show you that what do I mean. I have a cycle. These are the edges that I have, 1, 2, 3, and it goes all the way to n. If I consider one of these and I remove that, I said that, okay, this edge is the edge that I'm not gonna use. I'm sure that I'm not gonna use. The point is that the remaining parts, this circle turns into a path. Okay, so this circle that I had will turn into a path. And that is very good. Why it is very good? Because if I do that, then everything will be uniquely determined. Because between each A and B, for example, this is A and B, and there should be a path between them. There are 2 ways for them to have a path to each other. Either I should go this way, or I should go this way. But when I eliminate one of the edges, there will be only one path remaining. One of these paths will be corrupted. I cannot use them anymore, and I have to use the other path. So everything will be uniquely determined. It's like I have a path, and I have some intervals that I should not remove these intervals. Each of these intervals cover a set of the edges, and I want to be sure that I will not remove any of them. But some edges are okay, I can remove them as I want. So it would be something like this. And that is going to be very good. So now the point is this. Initially, let's assume that the edge that I'm not going to use is the edge between n and 1. Assume that I have removed this edge. I can have some sort of segment tree, and for each A and B, I can add everything in this interval by 1. So if an edge, I want to add all the edges in between of a and b by 1. And for each edge, if its value is at least 1, I will not remove it, I cannot remove it. If its value is 0, I can remove it. So I have two operations, just add an interval and count the number of zeros. The number of zeros. Okay, so add an interval and count the number of zeros. This is the two operations that I can solve using segment tree. We can easily do that. That is a very easy segment tree. And the point is that we initially said that, okay, I'm not going to use this edge. But the point is that how can I update this segment? The point is that assume that right now we are considering the possibility to remove, for example, this edge. We are considering the possibility to remove this edge. When I want to move on to the next edge, I say that, okay, I found out what is the best answer this way, and now I'm gonna go to the next edge. Now I want to consider the case where I will remove this edge instead. Well, the point is that when I go there, all the intervals that their value of a is in here, previously the path that must be added by 1 was this. So all these edges must have been added by 1. But now I will subtract this by 1 because now these edges must not be present, but instead these edges must be present. So it's like I subtract an interval by 1 and I add another interval by 1. And if this interval is circular, it's like a prefix and suffix, so it can be done with two operations. So I will subtract this by 1 and instead add this by 1. And also, when I move on to the next edge to be removed, when I remove this, I used to remove this edge, but now I'm removing this edge. If b of something was here, previously I had to use this path between a and b. So I have added them by 1. So now I will subtract them by 1. And instead, now that b is in here, I will now add this by 1. So each time when I move this edge that I'm not gonna use forward, I can easily update some of the edges, their values in segments, and I said that, okay, add these ones. Now these ones must be present. So this is how you can update everything and count the number of zeros in your segments. If I want to also show you my code, this is how it works. I see in n and m, ai's, bi's, and I have two vectors. These two vectors are for this. Whenever I reach somewhere, I want to know that what are the intervals that end here, their b is in here, and what are the intervals that their a is in here. I need to know these two values. Okay. So this is why I will use these two vectors, v1 and v2. And then I add ai to bi by 1 initially. Now this is the edge. Edge number t is the edge that I'm not gonna use. First I say ans is equal to minimum of ans and seg of 1 dot total. In seg of v dot total, I will keep that how many edges their value is at least 1. Their value is non-zero. And that easily can be calculated. If seg of v dot cnt add was positive, then all of them are non-zero. Otherwise, seg of v dot total is seg of lc dot total plus seg of rc dot total. This is a very well-known segment tree problem. So I just count that how many non-zero indices I have. So this is a classic segment tree problem that each time we add an interval or we count the number of zeros in the whole array. And this is in the whole array. I mean, we do not need to consider counting the number of zeros in an interval. It's in the whole array. So then I just have a 4 on v1. As I said, I must do this. For each a in here, I can remove this interval because this is not necessary anymore, and add this one instead. So what can I do is this. For I have a for I on v1 of t, I will add ai to bi by -1 and then add 0 to ai by +1, because I do not need this anymore. Instead, I need all the edges from 0 to ai, and I need all the edges from bi to n. And for all the intervals such that their b is in here, I first add ai to bi by +1, and then I add 0 to ai by -1 and bi to n by -1, because I'm not gonna need them anymore. And I just need ai to bi now. And each time I just do these updates and then get seg of 1 the total. And then I see out ants, and then I just clear segments and vectors. This is just a clear seg. I just make everything back to 0 to be ready for the next test case. And that's gonna be all. So it's just a segment tree problem. We just update everything. We try to keep a path instead of a cycle. We know that, okay, I'm not gonna use this edge. I know that there is at least one edge that I'm not gonna use. I say that, okay, I'm not gonna use this edge. Then all the other passes will be uniquely determined, and you know that which path you should use for the others. And when you know those values, then you can just use a segment to say that, okay, these edges must stay. When these edges must stay, I should add them in, add that interval in a segment to make sure that their value, to make sure that they will stay. And at the end, I just need to sum up how many edges have value 0, and nothing wants them to stay, and add those values up. So, is it clear? If you have any questions about it, tell me. Otherwise, I think we are done with this problem as well. Another solution to D using XOR hashing, I don't know. This is the solution that I used in the contest, but that's interesting. If another interesting solution exists, if I find the codes, I will attach the link of the code of such a solution. If you want, maybe you can send a code with that solution. I don't know if RNG used such a solution or anyone else. You can send that and I will add that to the description. Yeah. So yeah, you were saying for each edge, what do you do for each edge? It's Jiangly's codes. Okay, I will add that in the descriptions below. Oh, what a small solution. Let me see. AB f of a x equal to x. Oh, you XOR it with a random number, and you calculate prefix XORs. And you will see that what is maximum. Oh. It's weird. Oh, got it. Yes, cool. Yes, there also exists an alternative solution that is very, very more beautiful, and it's this much, this code from Jiangly, and you can see that he just X or some X with some values, you know, it has some value for each value. For example, f of a and f of b, it X or some random number with them, and at the end he finds the maximum number of positions that their prefix XOR is the same. Why that is good? Because, you know, all the indices that will not, all the edges that you will not use, all the edges that you're gonna remove, you can easily see that their XOR should be equal. Why? Because, you know, the point is that you have some A, you have some B. When you pass from A, definitely, I mean, at least one of these edges should be here. One of these edges should be used. So it's like for this pair of friends, A and B, for this pair of friends, either you will use this path or you will use this path. So when you pass over A or B, it's like the situation about the path between A and B will change. If previously, if you pass over A, if you already use the edge for the path between A and B, now you will not use the edges. If you were not using the edges, now you are using the edges. So it's like the situation changes. Whenever you pass over the endpoints, the situation about using or not using that edge for this pair will change. If you were not using the edge previously, now that you pass over one of the vertices, you are using. If you were using, now you are not using. So it's like when you XOR it, it's like a sign that something has changed. Some endpoint has been visited, so something that has changed. And the point is that all the edges that you will not use, you can easily see that all of them should have the same XOR, because if they do not have the same XOR, it means that at least for one pair, they have been between these two. I mean, for example, there is some A and B such that one of them is in middle of this and the other is outside, and it is not possible that you will not use both of them. So the point is that if you consider just random values and XOR them, you can make sure that you can find out all the positions. This is a hashing idea. You can find all those positions such that the situation of these intervals will not change. And you can just update those values. I mean, you can choose, you can see that what number is used the maximum number of times and use that. That was a very interesting solution. Thank you very much for sharing that. It was very, yeah. Yeah, it was, I think it was a very interesting solution. I really liked it. So the point is that when you use XOR, you are sure that all these, you know, the main point is this, you know, when you have some set of edges and you say that I will not use these edges, all the pair of friends, there must not be a friend. Consider two edges in here such that their XOR is different, their prefix XOR is different, their partial XOR is different. It means that there is some A in here and his friend is here in B, such that this has been calculated once and XORed, but it's not XORed back, and it makes the XOR of these two different. In this case, it's not possible to use both of these. So the point is that if the set of edges are going to be removed, you can remove them if and only if the XOR of the prefix XOR of them, the partial XOR of them are all equal. So this is how it works, and it is very, very interesting. Thank you for letting us know about this. Yes, the segment tree solution also works, but it is harder to code. But this is very shorter and more beautiful, and you know, its idea is more beautiful. So if I want to compare the code, this is the length of the code with this solution. This is the main part of it. For my solution on problem G, this is the code. As you can see, there are several functions for add, get, etc. Not get, add and clear, I mean. And this is way longer than this, but this is very shorter code that can solve the problem. Yeah, I liked it. Thank you. So, any other questions or comments? Once again, sorry for asking you that, but if you like the video, I think you can support us by liking the video or subscribing to the channel. I would definitely appreciate it if you do that. And also you can follow us on social media like Telegram and Discord, and its link, you can find the links in the descriptions below. I don't know if you can use DSU, but DSU it might be possible to do something with that. I don't know. But I think that still you need to do something else as well. Maybe you need to use some other data structures as well for this. Yeah, Ashish, I don't know what is the best, but if you mean the live stream, thank you very much. I'm glad if you liked it. Yeah. Awesome. So, any other questions or comments? Okay, so thank God the guy who was asking about my girlfriend is not here anymore, so I can go through with that. So, see you in the next time. Guys, I think 2 days from now, there's another contest, and we can keep in touch in Discord and Telegram as well. See you next time, guys.